1. On to, all right, so we've already talked about quadratics a little bit. We're going to continue our discussion of quadratic functions now. We're going to call them functions. In chapter 1 we called them quadratic equations. We know what a function is now, so we're looking at them as functions. And we want to be able to graph them and interpret a quadratic graph. So recall, quadratics were parabolas, right? So they looked either like this or like this. If it's this case, it has a maximum value and no minimum. If it's this case, it has a minimum value but no maximum. All right, so in this section, we're a little bit more concerned with these things, like what is the maximum value of the function, what is the minimum value of a function, what is that point, which we call the vertex, right? This is the vertex. We want to know what the vertex is. So things we're interested in for the quadratic, we'll just start with the most basic one. X squared. So we're interested in what is the vertex, where are there any x or y intercepts? In this case, the x and y intercept is 0, 0. In chapter 1, we found the x-intercepts, right? When we set the quadratic equal to 0, we were really finding the x-intercepts. So we've already done that. We'll do that again in this section. The things we're interested in, things we want to know. Want to know about quadratics. Where is the vertex? Where is what we call the axis of symmetry? The axis of symmetry is just the line that goes through the vertex. Right? Axis of symmetry. Intercepts, x and y. And let's see, anything else there? And the minimums and maximums, right? Min or max of the function. So that's what we're interested in this section. So let's look at something here. So again here, let's introduce the two different forms that we were looking at. Again, let me get the names straight. Again, it's general and standard. Always mix up the two. Standard form. All right, so we looked at the general form back in chapter 3. General form for quadratics. And that was our ax squared plus bx plus c equals y. Remember, y is the same thing as f of x. So now we're going to look at a second form for quadratics. And this is going to be y again, or f of x. And it's going to look like this, where hk is the vertex of the parabola. And in both cases, the a value here tells you whether the parabola opens up or down. Okay, so both here, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens down. And that's the same for this also. All right, so we want to be familiar with both of these forms. We want to be able to work with both of these forms to find out these things. Vertex, axis of symmetry, any x or y intercepts, and sketching a graph of the function. So let's go ahead and look at a couple examples here. All right, so I'm looking at number 18 in 3.1. All right, so this is a quadratic equation in standard form. on page 343, we're given this quadratic. All right, so that is in standard form. Notice the a value is 1, right? We don't see the 1 out in front, but we know it's a 1. So the a value is 1. The h value, so again, look at what we just said was the standard form. And pull out the vertex. So when it's in standard form, it's a lot easier to find the vertex than when it's in general form. It's not a big deal when it's in general form, but it's even easier when it's in standard form because it's right in front of us. We don't have to do any algebra. We just say x minus h. So the h value is 1 plus k, so the k value is negative 2. So we know our vertex is at 1, negative 2. So eventually we want to kind of sketch a graph of this, get an idea of what it looks like. So we're looking at this one here, x minus 1 squared minus 2. So we just said the a value tells us if it opens up or down. So this a value is 1, so that means it's opening upward. We know the vertex is at 1, negative 2, so we can kind of get an idea of what that is. It's down here, and that's going to be the low point, and we're going to have a parabola that opens upward. The axis of symmetry is just the vertical line that goes through the vertex every time. And remember, we discussed vertical lines. Vertical lines have equations that are just x equals whatever value that vertical line is going through. So we know this point is 1, negative 2. That's the vertex. And so what we want to know now is where does it cross the y-axis and where does it cross the x-axis. So back to chapter 1 to find the x-intercepts. We're going to do the same thing we did in chapter 1. We're going to set the function equal to 0 because that's where the x-intercepts are. So to find x-intercepts, we set y equal to 0. So we get 0 equals x minus 1 squared minus 2. So we're going to solve that for x. We're going to add 2 to both sides. We're going to take the square root of both sides, and in this case we are going to take both the plus and minus. So we get plus and minus square root of 2 equals x minus 1, and then we're going to add 1 to both sides. So 1 plus and minus square root of 2 gives us the x values where our x-intercepts are. Okay, so this is x-intercepts at 1 plus root 2, 0, and 1 minus root 2, 0. Now you don't have to be exact if you're asked to sketch the graph. You just kind of want to get it on the right side of the y-axis, right? So if you know square root of 2, it's a number that's a little bit more than 1, right? So we're adding a little bit more than 1 to 1 here. So this number is a little bit more than 2. It's a little bit more than 1, so this number is 1. And if we're moving a little bit more than 1, just kind of, we want to get it on the right side of the y-axis. So it's about here. And the x-intercepts for parabolas are always going to be equidistant from the axis of symmetry, right? Because that goes right down the center of the parabola. So the x-intercept, if it's this far to the right, it's going to be exactly the same distance to the left. And the y-intercept is easier. We just set x equal to 0. So we're going to say y equals 0 minus 1 squared minus 2. So that's negative 1 squared is 1. 1 minus 2 is negative 1. So the point 0, negative 1 is the y-intercept. And that makes sense with our graph. We have a parabola that looks something like that. So you want to label your vertex, you want to label your x-intercepts, you want to label your y-intercept, you want to label your axis of symmetry. So that's what we're interested in here in chapter 3. These are all going to be parabolas, either opening up or down. We want to know where's the vertex, what is the axis of symmetry, where are the x-intercepts, if any. Remember, sometimes if we try to find x-intercepts and we get imaginary numbers, that tells us there are no x-intercepts. There's always going to be one y-intercept, no matter what, because eventually it's widening out to infinity, so somewhere it's going to cross the y-axis, but it doesn't have to cross the x-axis. Right? So label axis of symmetry, x-intercepts, y-intercept, vertex, sketch the graph as best you can. If you get anywhere close on a graph, and if we're, I don't know what kind of tests we're going to be taking this semester. If it's online, you probably won't have to draw much, but you still have to know this information. Okay, so that is one example of graphing a quadratic. So let's look at an applied problem where we're looking for minimum or maximum value of a function. Let's look at, so that was a standard form. Let's do one in general form. Okay, so same thing we just did. We want to graph this quadratic. The previous one we did was in standard form, so it was easy to find the vertex. This time let's look at number 28 on page 343 and do the same thing, except this one is in general form. So there's a slightly different way to find the vertex. And we've already discussed in chapter 1 how to find the x and y intercepts for this. Same thing, we set this equal to 0, zero factor property, square root property, quadratic formula, all of that stuff. But we haven't discussed how to find the vertex. So when you have the quadratic given in this form, recall what form this is. This is ax squared plus bx plus c. Again, in chapter 1, we always let that be 0 to solve for the x-intercepts. Now we're just letting it be the whatever output it is. So to find vertex when in this form, the x-coordinate of the vertex is going to be negative b over 2a. So you identify what the a, the b, and the c are. In this case, you only need the a and the b to find the x-coordinate, and then you put that x-coordinate into the function to find the y-coordinate. Okay, so that's the kind of added step when we're dealing with an equation in this form. So if we come over here, identify our a and b is all we need. A is 1, b is negative 2. Again, be careful with the signs on these. A lot of people will forget that negative on the 2, but it is negative 2. All right, so now we can find the x and y coordinate for the vertex. Vertex x coordinate is going to be negative b over 2a. So that's 2 over 2, or 1. That's nice, right? Did I do that right? Negative b over 2a. All right, and then we're going to put that x value into the function. Right, this function. And evaluate that function. So that's a nice easy input. 1 squared minus 2 times 1 minus 15. So we got 1 minus 2 is negative 1. Negative 1 minus 15 is negative 16. So that's the y-coordinate of the vertex. All right. So I want to sketch a graph of this, or at least start it. Again, we look at this, the a value is 1, so we know it's a parabola opening upward, and we know the vertex is at 1, negative 16. And we'll put it somewhere about down here, pretty similar to our last graph. And we want the x-intercepts again, so this goes back to chapter 1. X-intercepts, we're going to set the function equal to 0. And again, hopefully, we always hope for the zero factor property. Looks like that one's going to work here, right? We can factor this nicely with a 3 and a 5, I think. All right, we want -2, so we're going to put a negative on the 5 and a positive on the 3. So that tells us our x-intercepts are at 5 and -3. So 5, 0 and -3, 0 are the x-intercepts. The y-intercept, this is pretty easy. We just set x equal to 0, so we get 0 squared minus 2 times 0 minus 15. So that tells us our y-intercept is at 0, -15. And now we can pretty much sketch the graph. We know where the vertex is, 1, -16. We know it opens up. We have our y-intercept at 0, -15, which makes sense with our graph. We have our x-intercepts at -3 and +5, which again makes pretty good sense with our graph. Our axis of symmetry always goes through the vertex, so that's x equals 1. And we kind of give it a cursory little picture. Again, we want to label our x-intercepts. We want to label the vertex, axis of symmetry, y-intercept, and x-intercepts. All right, so that's what we're trying to do here in chapter 3.1. Be able to take any quadratic in either of the two forms that we've talked about, general form or standard form, come up with the vertex, the axis of symmetry, x-intercepts, y-intercepts, determine what way it's opening, and be able to sketch the graph. All right, let's do one word problem dealing with these so we can look at what this is used for, what kind of questions we can answer. All right, so I'm looking at, what was that? Was that my computer? Okay. All right, what am I looking at here? Number 40, I think. I guess we could do number 40. Let's do number 40. So this is number 40 on page 343. All right, so this is, the question here is determine whether the function has a minimum or maximum, find that minimum or maximum, and find the domain and range. So the function given is 2x squared minus 8x plus 3, minus 3. Very important to get it written down right, otherwise you're going to frustrate yourself. 2x squared minus 8x minus 3. Okay, so first of all, the first question, so question 1 is, does this have a maximum value or a minimum value? And you find that out by looking at the a, right? The a, the value in front of the x squared term. This is in general form, right? 2x squared, ax squared plus bx plus c. The a value is 2. So the answer to this, you don't have to exactly write all this out, but this is why. Since a is greater than 0, this function has it opens upward, so it has a minimum and no maximum. Right? Because we know it opens this way. Goes up forever, and this is going to be the minimum value. The y value, the output, is when you're asked for the for the minimum or maximum value. You're looking at the output of the function, right? The lowest output of the function. All right, now we want to find out what that minimum value is. So basically what you're being asked to do here is find the vertex. That's really all we're being asked to do. So, what is the minimum? Question 2. What is the minimum value of the function? And where does it occur? That's the x value. What input? So that's the form that these questions are going to take. What is it a maximum or a minimum? What is that maximum or minimum? What's the input that gives that maximum or minimum? Okay, so we're looking at this function here. We're saying a is 2, b is -8. So the vertex, remember, is at -b over 2a, and then the function evaluated for that value. So we just got to come up with that value using this. -b over 2a is going to be -b over 2a. So that's 8 over 4, or 2. That's the x-coordinate. And the y-coordinate, we put that 2 into the function, and we get 2 times 2 squared minus 8 times 2 minus 3. So we got 4 times 2 is 8, minus 16 minus 3. So it looks like minus 11 is the y value. Right? XY vertex. Did I do that right? -8 minus 3, -11. Okay. So now we have the vertex, and we can now answer the question. We determined that it had a minimum and no maximum, so we know the minimum value is going to be this. This is the minimum value of the given function, and it occurs at an x value of 2. And that's your answer. So these are the things we want to be able to analyze about quadratic functions.